Okay, here's what happened. The memory on the camera filled up and cut off just as we were getting to the good part of the dissolved oxygen experiment. What I've done is I've saved the original batch here, and as you can see, this is cleared up completely from what it was. Remember, it had a few little brown particles still floating. Okay, we are supposed to take 5 milliliters of this liquid, put it in our smaller container here, so 5 milliliters. Then we are supposed to add 1 drop of the starch indicator. Notice how beautiful and yellow that is. We're going to add 1 drop of starch indicator. And we have now changed this from a beautiful yellow to almost a black. And the kids call this a black, but this is actually supposed to be a deep, deep blue. Then we're supposed to add drops of our titration. Now remember, each drop is approximately 0.3 milliliters. So 3/100ths of a milliliter. So here we go. We're going to do this 2 drops at a time, and we're going to get this to change from blue to clear, and it's going to change all of a sudden. I'm going to do this 2 drops at a time. So we add our 2 drops. Here we go. 1, 2, 3, 4, 5, 6, 7, 8. Okay, as you can see, it's starting to clear a little bit. 9, 10, and clearing up quite a bit. 11, 12, 13, 14. Whoa, it's almost there. 15, 16. And guess what? Boom. We've now gone to clear. 15, 16. So, 16 drops for our dissolved oxygen. And on this, our dissolved oxygen. So our questions were, did we get a precipitate? Yes. Did the precipitate dissolve? Yes. Did it turn yellow? Yes. How many milliliters did we use? So we used 16 drops, and each drop is 3/100ths of a milliliter. So 16 over 1 times 3/100 equals, let's see, 16 times 3 is 18, is 48. We have 48/100ths. So how many milliliters? Well, this is 1 milliliter. It's actually, it's 0.48 milliliters. Multiply this number by 10.48 times 10, and we get 4.8 milligrams per liter of dissolved oxygen. And according to our scale, 0 to 5 is low. Anything over 5 is high. What is our sample? Our sample is 4.8. It is near high. And as a matter of fact, for most fish would be able to survive in this. And considering that this water is coming from underground, its dissolved oxygen content is very high for us. So we're going to call this, we could actually round it up and say 5, but we're going to call it 4.8. We're going to be precise because we want to be precise. And that concludes our dissolved oxygen experiment. So this water, very, very good. And remember, dissolved oxygen, the more oxygen, the less chance that there's anything growing in it, because oxygen kills bacteria. Oxygen kills many of the organisms that grow in water. So the higher the oxygen level, the better the water is for us as human beings if we wanted to drink it. And that concludes the dissolved oxygen experiment.